Good morning, children. In continuation with Chapter 3, Current Electricity, today's topic is cells. Let's start.
The cell can maintain a potential difference across a resistor to give a steady flow of current in the resistor. As the current keeps on flowing, the positive charges keep on accumulating at the negative terminal of the cell. Unless these positive charges on negative terminal are constantly transferred to the positive terminal through the electrolyte inside the cell, the potential difference across the two terminals cannot be maintained constant.
Now you already have done in your previous classes about the cell, that is electrolytic cell. This is the arrangement of electrolytic cell. Here we have taken the two electrodes, positive and the negative terminal, and they are connected with the resistor R. This is the external resistor. And we have an electrolyte here. Now since it is a chemical reaction going on inside the cell, so once the chemical reaction is started, the positive charges are accumulated on the negative terminal of the battery and negative charges are accumulated on the positive terminal of the battery, and the current will flow in the circuit. And since the potential difference across the two terminals cannot maintain constant, once the chemical reaction is started, after some time they will not maintain a constant current because all the negative charges are on the positive terminal of the battery and the positive charges on the negative terminal of the battery. Therefore,
work is required to be done for transferring the charges from one terminal to the other through electrolyte inside the cell, since the electrolyte medium offers resistance against the movement of charges. This is called the internal resistance of the cell. Against the movement of charges. This is called the internal resistance of.
now during the chemical reaction which is going inside the electrolyte, the work is done in moving the charges from negative to the positive terminal, transferring the charges from one terminal to another inside the electrolyte. तो यहाँ पे inside the electrolyte there is a work done. वर्क डन क्या हो रहा है यहाँ पे, यहाँ से चार्ज इधर जा रहा है, नेगेटिव द पॉजिटिव टर्मिनल जा रहा है, तो यहाँ पर आपका देर इज और यहाँ पे क्या हो रहा है, वर्क डन हो रहा है. तो दिस वर्क डन, ड्यूरिंग दिस वर्क डन सम रेजिस्टेंस इज ऑफर्ड बाय द दिस इलेक्ट्रोलाइट. जो इसके अंदर का इलेक्ट्रोलाइट है या लिक्विड बेस जो है वो एक तरह का रेजिस्टेंस ऑफर करता है. दिस इज कॉल्ड द इंटरनल रेजिस्टेंस ऑफ द सेल. उसको हम इंटरनल रेजिस्टेंस बोलते हैं सेल का. एक्सटर्नल तो आपके पास ये हो गया जो हमने वायर के साथ कनेक्टेड किया. अब जो चार्जेस को एक इलेक्ट्रोड से दूसरे इलेक्ट्रोड पे जाने पे जो भी वर्क डन करना पड़ रहा है अगेंस्ट द रेजिस्टेंस ऑफ द इलेक्ट्रोलाइट इज कॉल्ड द इंटरनल रेजिस्टेंस ऑफ द सेल.
Of the cell. EMF. The work done per unit charge to force charge to move from lower to higher potential terminal inside the cell is called the electromotive force of the cell.
Now this is the representation of the cell and this is the internal resistance जो अभी हमने पढ़ा, internal resistance which is denoted by R, and E, that is the internal electromotive force, that is called EMF. The work done per unit charge to force charge to move from the lower to the high potential. वर्क डन हो रहा है फ्रॉम लोअर टू द हाई पोटेंशियल में चार्ज को मूव करने के लिए इनसाइड द सेल इज कॉल्ड इलेक्ट्रोमोटिव फोर्स ऑफ द सेल. तो यहाँ पे जो चार्ज को मूव करा जा रहा है फ्रॉम हायर टू द लोअर पोटेंशियल, lower to the higher potential inside the cell is called electromotive force of the cell.
EMF of the cell is given by E is equal to I within parenthesis capital R plus small r. Here capital R is the external resistance, small r is the internal resistance, small I is the current in circuit. An ideal cell has a zero internal resistance. The voltage applied to the circuit is equal to the EMF of the cell.
Now this is the formula to calculate the EMF of the cell. E is called the EMF of the cell. I is the current flowing in the circuit. Capital R is the external resistance and small r is the internal resistance of the cell. For an ideal cell, internal resistance is 0. For an ideal cell, we imagine the internal resistance of this particular cell is 0. The voltage applied on this circuit is equal to the EMF of the cell.
Cells in series and parallel. Cells in series combination. In series, cells are joined end to end so that the same current flows through each cell. In ordinary series connection, the positive terminal of one cell is connected to the negative terminal of the second, the positive terminal of the second to the negative terminal of the third, and so on. When cells are connected in series, the EMF of the battery is equal to the sum of the EMFs of the individual cells.
Now when the cells are combined in series, जब हम series में cells को लगाते हैं तो alternate connection करेंगे positive and negative का. You already know about this. जब हम किसी भी बैटरी के अंदर या किसी भी रिमोट के अंदर लगाते हैं तो cells are in the series और वहीं पे हमारा एक negative और एक positive के साथ ही cells को join करते हैं. When the cells are connected in series, the EMF of the battery मतलब ये जो सारा पूरा EMF of the battery is equal to the sum of EMF of the individual cell. तो यहाँ पे अगर हमारा cell 1 है तो इसका EMF is 1 और इसका internal resistor is R1. ये second battery है, इसका EMF is E2 and internal resistance is R2. ऐसे ही third one battery है, internal resistance R3 and EMF कितना है इसका E3. तो combined EMF कितना होगा? Sum of E1 plus E2 plus E3. The EMF of the battery is equal to the sum of the EMF of the individual cell.
The total internal resistance is equal to the sum of the individual internal resistances of the cells.
Now the total internal resistance जो पूरे internal resistance of the cell जो होगा that is R1 plus R2 plus R3. ये सबका internal को हमने add up करना है.
The current in each cell is the same and is equal to the current in the entire series combination.
And the current flowing in this circuit is also same and is equal to the current in the entire series combination. अगर इसका है series combination का जो भी हम current निकालेंगे वो same equal to होगा जो circuit में flow करेगा. तो I यहाँ पे भी same होगा, यहाँ पे भी same होगा और यहाँ पे भी same होगा.
If n identical cells, each of EMF E and internal resistance R are joined in series, the current in the circuit is equal to NE divided by R plus N.
If n identical cell are joined, अगर यहाँ पे अभी तो 3 है और 4, 5, 6 n times यहाँ पे add up कर देते हैं तो each of EMF E and the internal resistor R are joined in series. The current in the circuit is given by this formula. N is the number of cells कितने हमने join करें 1, 2, 3, 4, 5. In this case is 3. R is the external resistance plus N R small r is the internal resistance जो इनका R1 plus R2 plus R3 plus Rn तक add up करके जो final internal resistance आएगा that is R.
R. Cells in parallel combination. Cells are said to be connected in parallel when the current is divided among the various cells. In ordinary parallel connection, all the positive terminals of the cells are connected together and all the negative terminals are connected together. When identical
Now cells in the parallel combination, cells are said to be connected in parallel combination and the current is divided among the cell. Now you can see that the cells are connected in parallel combination. In series we have seen that the negative and positive terminal are connected alternately. ठीक है, नेगेटिव को पॉजिटिव के साथ फिर नेगेटिव पॉजिटिव. बट इन द केस ऑफ पैरेलल कॉम्बिनेशन all the positive terminal are connected with one side and all the negative are connected at one side. Here the current flowing in the circuit is equally divided in all the three cells. यहाँ पे I1 रहेगा, I2 रहेगा, I3 रहेगा. R1, R2, R3 are the internal resistance of the cell and E1, E2 and E3 are the internal EMF of the individual cell.
Particle cells are connected in parallel. The EMF of the battery is equal to the EMF of a single cell. The reciprocal of the total.
Now when the cells are connected in the parallel, the EMF of the battery is equal to the EMF of the single cell. So EMF of the battery is equal to the EMF of a single cell के equal होगा. The reciprocal of the total internal resistance is equal to the sum of the reciprocal of the individual resistance, internal resistance of the cell. R इस पूरे सिस्टम का कैसे निकालेंगे, जैसे हम निकालते थे, जैसे 1/R इज इक्वल टू 1/R1 प्लस 1/R2 प्लस 1/R3. वही सेम मेथड से इस पूरे अरेंजमेंट का हम R निकालेंगे.
Internal resistance is equal to the sum of the reciprocals of the individual internal resistances of the cells. The current in the external circuit is divided equally among the cells. If n identical cells, each of EMF E and internal resistance R, are joined in parallel, the current in the circuit is equal to NE divided by NR plus R.
So when the cells are in a parallel combination, the current in the external circuit is divided equally. तो करंट जो आपका होगा वो इक्वली तीनों में डिवाइड किया जाएगा. सपोज अगर 3 ohms करंट जा रहा है तो 1 ohm यहाँ जाएगा, 1 ohm यहाँ जाएगा, 1 ohm यहाँ जाएगा. If n is the identical cell, each EMF E, सबका EMF E आता है, and R is the internal resistance, वो हम सीरीज और पैरेलल कॉम्बिनेशन से R निकाल लेंगे. आर ज्वाइंट इन पैरेलल. द करंट इस केस में I इज इक्वल टू E अपॉन जो आपका EMF कैलकुलेट करेंगे वो अपॉन R, दैट इज द एक्सटर्नल रेजिस्टेंस, प्लस स्मॉल r इंटरनल रेजिस्टेंस ऑफ द कंप्लीट बैटरी अपॉन N. After solving this, you will get this relation. Today I am end up with the session, the cell in series and parallel. We continue the chapter in the next video. Good day, students.